Right, you see this one? The first one. We take 5 out of each one, so what's left if we take 5 out of each one?
0, 10, 5.
Alright, if you take 5 away out of 5x, what's left?
X.
It's not enough, a lot of room for this one. If you divide 5 into 15, you get?
Y.
3y.
3, y.
Alright, so because 5 times 3y is 15y, isn't it?
Yeah.
And what about the minus 10c? Divide 5 into minus 10?
2.
Minus 2c is the answer there. Can you see that?
Yeah, that's it.
Z, sorry, minus 2z. Right, the next one. So here you have to take factorizing in pairs. So in the first one you take m from both sides. Now when you take m out, what's left?
P.
P plus 2. Now this side minus n is taken out.
P.
So P
2.
plus 2 again. Right, so what are the two answers? M minus n
Or P plus 2.
right?
Yeah.
That's okay. Now the next sum here. X squared plus 11x plus 24. We have to write down the factors of 24. 1 times 24.
2 times 12.
2 times 12. 3 times 8. 4 times 6. Which pair will add up to 11?
3 times 6.
3 and 8, won't it?
3 and 8.
Sorry, it's over there. 3 and 8. Alright. Turn around. So we're looking for the factors. It says up here, factorize. Look for the factors. So we write down x, 8, and 3. To get plus 11, we need plus 8 and plus 3, don't we? Factorize. We stop at that point. We don't go any further. Page 82. The next one. This is called the difference of two squares. 81 is a square number. Why is that?
81
9 is its square root.
Because if you
Yes.
9 by 9.
9 by 9 is 81. So we have the difference of two squares. Okay. So, what's the answer? I put in C and 9 and C and 9. So we need that. What signs do we need? Minus and a plus or plus and a minus.
Why is that?
Plus and a minus makes a minus.
Right.
Right, question 12. Tom sets Mary a word problem. If I multiply Dad's age by 3 and add 25, see it here? So Dad's age is X. The result is the same as multiplying Dad's age by 4 and taking away 20. So it's the same as multiplying Dad's age times 4 and subtracting 20. Is that okay? Finish the equation, so I'll just write down the equation here. 4x minus 20. How do you show that what?
Where did you get 4x?
4x. It's the result is the same, so equals as multiplying Dad's age. Dad's age is X. Dad is X by 4, so that's 4x. And taking away 20. 4x minus 20. Right, the next one. Solve the equation means get the factors and then find the value of x. Are you, have you got this done?
No.
Have you got this done?
No, I haven't, because I only had most of it, but I did get some.
Alright, get your pen and copy it down. What's the factors of 6?
1, 2,
Which pair adds up to 5? So we have x, 3, x. How do we get minus 5 with 3 and 2?
plus and minus.
Minus and plus.
No. How do we get to minus 5?
Oh, plus 3.
No, minus 3 and...
Minus 3, minus 2.
If you add minus 3 and minus 2, you get minus 5. On the number line here, watch. There's minus 3, and I take minus 2 steps. Minus 5. Right? So you have minus 3 and a minus 2 to get minus 5. Alright, so that's factors. I need to solve. Solve means finish it, another step. So we have x minus 3 equals 0. Sorry, x minus 3 is equal to 0. Move the minus 3 across. X is equal to 3. Alright, and then up here we have x minus 2 is equal to 0.
Minus 2.
X is equal to,
Minus 2.
move the minus 2 across.
Plus 2.
X is equal to plus 2. So the two answers are x is equal to 3 and x equal to 2. Okay? Next page. Top page 83. Solve the inequality. So we have to draw our answer on this number line. X, so the x, this means up here, this means the answers must be natural numbers. What are natural numbers? 1, 2, 3, 4, 5, 6.
Not minus.
Yeah, doesn't include
Not
0,
decimal and
not 0 and not minus numbers.
decimals
No decimals
or fractions.
or fractions. So the first thing we do is we write down the equation. 4x minus 7. Alright, now we go 4x. Treat this sign as an equals. So far, and bring the minus 7 across and it becomes plus 7. What's 7 minus 3?
4.
4x is greater than 4. What do we divide both sides by? The number in front of the x. 4 into 4 goes
1.
once, and 4 into 4 goes once. Now, do you see the n? So we're going to put dots everywhere that x is greater than 1. There are my answers. Greater than 1, do we include 1?
Yeah.
Yeah.
Greater than 1.
2 and 3.
No, true and 3. They're the only answers that we can scribble in. Alright, now for the graph, we'll move on to the graph. We have to fill in the values onto the graph. Alright, 2010, so we have to mark off 10,500. So 10,000, sorry, 10,000 is way up here, and 500. That point there. So in 2011, we have to go up to 9,000. 2012, if you go up to 7,500. 2013, we have to go up to 6,000. Or we can get a ruler and we can draw a line through all the dots if you like. So the question was, John bought a car in 2010. He noted in its value each year it was reducing every year. How much was it reducing every year by?
1,500.
Yeah, 1,500. So every year it was coming down by, see that? Can you include that in your diagram? So every year it was coming down by 1,500. So from the graph, because I drew a straight line, I can tell how much it's worth in 2014. I can tell how much it's worth in 2015. Is it worth any money in 2016?
Yeah.
Is it? Look at my graph.
Yeah, it's 1,500.
Huh? That's 2015.
No,
See?
2016 is 1,500.
2016, I'm predicting it's not worth any money, huh? Right, we'll have a look. What are the questions? On the next page.
Oh, that's given. No, it's
So that's 2016 to last one. So that's one.
is what is linear?
Oh, you're right, yeah, sorry. Okay, what? First one. Is the pattern linear? Explain your answer. Linear, is it a straight line?
Yeah, because it goes down here.
Yeah.
Straight.
Is it linear? Yes, it's a straight line. If the pattern continued, what would the car value be in 2015? 3,000. In what year is the car worthless?
2017.
2017. Write a formula in words to represent the value of the car of John's car each year.
Decreasing by 1,500.
Yeah, 1,500.
It's decreasing. What does it start off at?
Each year.
What does it start off at? 10,500, isn't it?
No, this is a different car now.
Write the
Oh, no,
formula.
sorry.
John's car. It starts off at 10,500.
But what year is that?
All right. That's year 0.
2010.
And what do we subtract every year? We subtract.
1,500.
Okay. So we'll put down year times 1,500. So if the year is after 1 year, 1 times 1,500, and you subtract it from 10,000. All right, that will work, won't it? So if the year is 2, if y is 2, we subtract 3,000. Yeah?
I think it's worthless in 2016 or 2017.
It is 2017.
2017. So it's where the line crosses the y-axis. That was 2017. Michael bought a car in 2011 for 8,000. By 2013, his car had a value of 5,500. Show these two results in the diagram. So 2011, 8,000, 2013, 550. So we'll draw that out. 2011, 8,000, and 2013, 550. That's it, isn't it? Alright. Show these two results on the diagram. Do you think Michael's car is losing value faster or slower than John's car? This is Michael's car, this line here. Is he losing money faster or slower? Michael's car here. Slightly faster. Because? No. Michael is losing it. This guy is moving it slightly slower. Because the slope is not going down so steep.